Welcome back to Electrically Constructed. I'm Master Electrician Seth Eckel, and this is video number 7 of our box fill calculation series. In the last video, we covered equipment and device fill, and in this video, we are going to go over clamp fill. That is going to be Article 314.16b2. If you don't have a code book, I got a link below. You can go there and buy a code book if you like. Otherwise, if you got a code book, why don't you get that out and get to Article 314.16b2. And let's get going. All right, let's get your code book out, and we are on 314.16b2 clamp fill. Go ahead, grab your highlighter, and let's highlight that right away. All right, where one or more internal cable clamps, whether factory or field supplied, are present in a box, a single volume allowance in accordance with Table 314.16b4 shall be made based on the largest conductor present in the box. No allowance shall be required for a cable connector with its clamping mechanism outside of that box. All right, that's pretty easy one, pretty easy to understand here, but we're going to break it down even more. Just highlight one or more internal cable clamps are present in a box, a single volume allowance in accordance with Table 314.16b4 shall be made based on the largest conductor present in the box. All right, that's it. Let's switch views and take a look at some of these examples. All right, so basically what this code rule is telling us is that if we have internal clamps in our boxes, like these metal ones here in this box, or these plastic style here in our residential boxes, the clamps that hold on our Romex as they get pushed through, they are worth one conductor volume allowance of the largest conductor inside that box. So basically you just have to add one of the conductor volumes. If you have 12s and 14s in there, you're gonna put 2.25 conductor volume allowance, add it to the box because you have internal clamps inside there. If you don't have internal clamps, you don't have to use that rule. If you're using external clamps like MC connectors, such as this style MC connector, any type of MC connector, NM connectors, those don't add volume to your box either. The clamp style connectors, they don't add volume to your box either. If it's clamping, if it's being pushed through the KO, it doesn't add volume to your box. So it's probably a better choice to use most of the time. But if you use these, it doesn't matter how many are in the box. You only have to add one volume allowance of the largest conductor if you are using internal clamps. All right, pretty simple. Just remember, it doesn't matter how many wires are going into the box, how many clamps you have in your box. They just add one conductor volume allowance based on the largest conductor present in that box. And that's it. All right. Let's get our calculators out. Let's get some scratch paper out, and let's do a quick couple code questions here. We'll use all the code rules that we've learned so far and see if we can figure them out. All right. All right. So here's our question. How much volume does this box have in it, and is it code compliant? Will we pass inspection with everything that we have installed in it? So let's go through it together. All right, I have a 12-2 MC cable going into the box. I have a hot, a neutral, and a ground coming into the box. I have a equipment grounding conductor screwed to the back of the box. I have 12 gauge pigtails. I got a hot, 2 hots, 2 neutrals, and 2 equipment grounds attached to 2 devices. The raised cover has a 7 cubic inch stamp on it, and we are using a 4 square by 2 1/8 deep box. How much volume do I have in this box, and is it code compliant? You can pause the video and unpause it when you're ready, and we'll go through it together. All right, welcome back. Let's go through this together and see what you got. Okay, we have a 12.2 MC cable entering the box. Let's put that up there. Let's see what that gives us. So we have 12.2 MC, that's 3 number 12 gauge wires entering the box, your hot, neutral, and ground. So 3 12.2 cables is 2.25 cubic inches times 3. And that's going to give us 6.75 cubic inches. All right, so that's just for the wire entering the box there. Okay, next we're going to add in our devices. We have 2 devices attached to this box here, and we know from our code rule, our device and equipment fill rule, that each device taking up a single gang equals 2 of the largest conductor wire allowances attached to that device. So that would be 12 gauge wires times 2 for each device. So that would give us 4 more 12 gauge wires. Put that on here. All right, so 2.25 times 4 equals 9 cubic inches. Okay, so far we got the 6.75 cubic inches and the 9 cubic inches. Anything else that needs to be added to this box? We got wire nuts. We have an equipment grounding conductor. What else we have? We have these pigtails attached to the devices. Do any of those add volume to our box? Let's find out. Nope. Pigtails do not add volume. So the pigtails that are coming off the devices don't add volume. The equipment grounding connector that is attached to the box does not add volume. And wire nuts do not add volume to our box fill calculation. And we also know that if these equipment grounding conductors that are pigtails and already inside the box did add volume, the first 4 would only equal 1 conductor anyway. All right, so let's see here. We have everything counted up now, and that's 6.75 plus 9 gives us 15 cubic inches of volume that is in this box. So that will give us our first answer. We know now that we have 15.75 cubic inches of volume in the box. Now the second question would be, is that code compliant? Does this box allow us to have that much volume in it? So we already know that this is a 4 square by 2 1/8 deep box. So we have to go to which table? We have to go to table 314.16a. And then we have to look up our 4 square by 2 1/8 box, and that gives us 30.3 cubic inches of volume. So we have way more than enough, almost double the allowance for this box with what we have in it. And we have quite a bit in it already. We have 2 devices, and we have an MC, and we have 6 pigtails coming off the devices, and we have a pigtail on the back of the box, and we have plenty of room left in this box, and we still have the raised cover that we can add onto it. We know that the raised cover is 7 cubic inches, so let's add that to it. And we got raised cover with 7 inches plus the 37.3 cubic inches of volume that we could actually use for this box. So yeah, no worry at all here. We are good to go. Let's go with one more code question. Hopefully you got this one right. If you didn't, go back, see where you got it wrong, slowly walk through it and try to figure it out. Get it right before you move on. It's better to understand it and get it right before you just try to blow it off and come back to it, or blow it off and try to figure out later on. Figure out now. You're in the process right now. Just go back, walk through it one more time and see if you can get it. All right, but if you did get it, let's move on and let's try this next challenge question here. All right, so we have this plastic PVC box here, which is 20.3 cubic inches with volume allowance in it. And I got a GFCI attached to it. I got my home run coming into the box, 12.2 cable, and then I'm going to run around the kitchen. I'm going to go one way with the 12.2 cable, and I'm going to go the other way with the 12.2 cable. So I have 3 12.2 cables entering the box, and I have 3 pigtails coming off of the device, with wire nuts on it. And it is a plastic box using internal clamps. So am I code compliant? Go ahead, pause the video, take your time, try to work it out. And when you're ready, unpause it and we'll work through it together. All right, let's walk through this one together. Okay, so we have 3 12-2 Romex cables entering this box here. So that's going to give us 3 hots, 3 neutrals, and 1 equipment ground. That's 7 wires that we have entering the box that we have to add into our calculation. So let's look at that. We know that 12 gauge wire is 2.25. So 2.25 times 7 equals 15.75. So right off the bat, we got 15.75 cubic inches in this box already. All right, then we got our device. That's going to be 2 wire volume allowances based on the largest conductor attached to that device, because it's a 1 yoke taking up a single gang. So that's going to be 2 times 2.25 times 2 equals 4.5. So now we got 4.5 added in with this device. Next, let's see, we have clamps. So we have an internal clamp on this box. So all your internal clamps. So I got 2 going on, and I got 3 wires going into the box. But internal clamps only add 1 volume to your box fill calculation based on the largest conductor in the box. So that would just add another 2.25 cubic inches. All right, so now we have 15.75 cubic inches plus 4.5 cubic inches plus 2.25 cubic inches. That should take care of everything that we have to add up for this box here. Now remember, this box is good for 20.3 cubic inches. If I can see it, I just want to double check. Yep, 20.3 cubic inches of volume is allowed in this box. And all this added up is going to come to 22.5 cubic inches. We just failed inspection. So, good to know that before you start putting all this wire in your box and making a lot of extra work for yourself. The inspector shows up and he's happy to fail you because that's what he likes to do. No, he just needs to make sure that we're following the rules, and this wouldn't have passed inspection. So know your code calculations, look at it before you install so that you get it right the first time and don't have to redo the work. Hopefully this all made sense to you, and that will be the end of this video. Next video we are going to cover, let's take a look what's going on in the next video. We are moving on to, that's why I can't see it. Get that out of the way. Support fitting fill. All right. So we covered cable clamps today. Support fitting fill is in the next video. All right. Stay sharp. Never stop learning, and God bless. Can't wait to see you in the next video.